Let's start with our next question, that is question number 28. Now this question belongs to a section of electromagnetism of chapter capacitor. As per the question, a parallel plate capacitor with plates of area 1 meter square each and separation of 0.1 meter. If the electric field between the plates is 100 Newton per coulomb, we have to find the magnitude of charge. It's a very easy question, formula based one. Let's start with the solution. As you are well aware of the formula that electric field can be written as sigma by epsilon naught, and sigma is basically Q by A epsilon naught. So for charge I can write A E epsilon naught as this value. So what is the value of area? Let's see. As per the question, area is 1 meter square and electric field is 100 Newton per coulomb. So I'll just put the value 1 into, this is 8.857 into 10 to power minus 12, and what is the value of electric field? That is 100, right? On solution you will get Q is equals to 8.85 into 10 to power minus 10 coulomb. Let's see which is the best suited option here. As you can see, option number 1 would be the right answer for this question, right? Let's move ahead and see question number 29. Now the question you see belongs to a section of mechanics, basically rotational motion. Here there are two particles A and B which are moving around a common center in concentric circles, but the direction of motion is opposite. So we have to find their relative velocity at a particular time of pi by 2 omega, right? So very first thing, let's start with the solution. We have to find that after this amount of time where the particles will be. Both are moving with the same speed omega. So I'll say the angular distance which will be covered would be omega into t. So you say omega, and from here you will write pi by 2 omega. Thus theta would be simply pi by 2. So after this amount of time, this particle A will reach at here and this particle B will reach here. When it is at this point, the velocity of A will be in this direction and velocity of B will be in this direction. Now let's see what is the value of VA and VB. As per our analysis, it is minus R1 omega I cap, and velocity VB would be equal to minus R2 omega I cap, and both are in vectorial form. When you want to find the relative velocity of A with respect to B, you will write it as minus of R1 omega I cap minus of minus R2 omega I cap. Simplifying this, you will get omega as R2 minus R1 I cap. Let's see which is the best suited option here among the given ones. You have option number 1 as the right answer, right? Let's move on to our last question of this paper. So this question here belongs to a section of oscillation waves. As per question, a resonance tube is old and has jagged end. It is still used in the laboratory to determine the velocity of sound wave in air. A tuning fork of frequency 512 Hz produces first resonance when the tube is filled with water to a mark of 11 cm below a reference mark. That means there is an end correction, and what's the value of it? It's 11. The same experiment was repeated with another tuning fork of frequency 256 Hz and the end correction found was 27 cm. What we have to find is the velocity of sound wave in air. Let's start with the solution. So for the case of first resonance, I'll say that wave formed that lambda by 4 would be L naught plus E, that is end correction 1, and this lambda would be wavelength 1. In the second case, let's take as lambda 2 by 4 would be equal to L naught plus E2, right? On solving this, what you will get is, let's take this as equation 1 and this as equation 2, and subtracting 1 from 2, I'll get lambda 2 minus lambda 1 by 4 is equals to E2 minus E1. What's the value of E2? That is 27, and what is E1? 11, so it would be 16. Solving this, you will get lambda 2 minus lambda 1 as equals to 64 centimeter. So I have lambda 2 and lambda 1 with me. Now from here, I can also write lambda 1 as velocity of sound wave by frequency 1, which would be equal to V by 512, right? And lambda 2, similar lines will have V by F2, that would be equal to V by 256. Now let's just put down the values here. So I'll get V by 256 minus V by 512 should be equal to 64. No, it is in centimeter and this is a standard value of hertz. So I'll write 0.64 to convert it into meters. Now just take V common, so it will be 1 upon 256 minus 1 upon 512, that would be equal to 0.64. It's now easy to calculate it. You will find the value of V would be equal to 328 meter per second. Let's see which is the best suited option here. So in this case, option number 3 would be the correct answer for this question. So I hope this was clear to you. I wish you all the best for your results. Thank you.